afternoon. I am aware that I have the pre-lunch slot and we still have questions to go, so I will try and keep this moving. So I'm going to be talking to you today about thorough examination and testing of local exhaust ventilation systems, what you need for your LEV system, how to look for or how to employ a competent examiner, and also what needs to be in the report. So this is just a list of legislation and guidance that you should be aware of. All of this is free to download, and there's a wealth of information in there. If you need pointed in the right direction or you're not sure about something, I would certainly point you towards this documentation first. So Control of Substances Hazardous to Health, or COSH, states that LEV systems need tested at least every 14 months. This is the minimum interval for testing. You shouldn't exceed this, and it is a legal requirement. This is unless it's stated specifically in COSH Schedule 4, which has a number of processes which have a more frequent testing interval. So it's as often as 1 month if you're working in certain processes. And the onus really is on the employer, so I would certainly recommend that you get that done. So in terms of COSH regulations, Regulation 9 covers the maintenance, examination and testing of controls. So this covers local exhaust ventilation, thorough examination and test. It states that every employer must ensure all controls are maintained in an efficient state, efficient working order, good repair and clean condition. And as you can see again, it is definitely putting the onus on the employer. The objective is to ensure that all control measures perform as originally intended, and most importantly, continue to prevent or adequately control exposure. So why do I need a thorough examination and test? So as it has been mentioned several times today, welding fume has been reclassified as a carcinogen, so it is cancer causing, and we do know that. The HSE states that there's no known level of safe exposure to welding fume. Therefore, control has to be as low as reasonably practicable. Often people aim for the workplace exposure limit and think that that's low enough, and it isn't. You really do need to control as low as you possibly can. In an ideal world, you'd actually just eliminate it completely or substitute it for a safer process, but you really must control as low as possible. An LEV system is all well and good, but if it's not being used properly, such as this welder here, that LEV hood, I'm sure the capture hood works perfectly well, but where it's positioned, it's not close enough to the exposure source. And as you can see, there is welding fume escaping into the worker's breathing zone. This is not what we want to see. So ultimately, you need a thorough examination and test of your LEV system to protect your employees. Their health is of the utmost importance, and it really is vital that you do get your system tested. As I've said before, and I don't think I can state it enough, you must ensure that the exposure is reduced as low as reasonably practicable. Respiratory protective equipment has been discussed by a few of the other speakers, and it is used often because people think it's the cheaper form of control, and actually in the long term it isn't. It's also at the very bottom of the hierarchy of control, so it's the least effective control measure. You want to start, if you can, at all possible, look at elimination of the process. See if you can take welding out of it completely. If not, have a look at substitution. Can you substitute for a less hazardous material? Failing that, you're going to have to start looking at engineering controls, of which local exhaust ventilation is one. The further down you go, the hierarchy of control, the more controls you'll need to put in place. So for instance, if you're just going straight for RPE, you're going to then need to put in place rotation of staff and make sure that their exposure is reduced as much as possible. So really LEV is one of your best forms of control. So in terms of routine checks, you should be making routine checks on your LEV system. You, as an employer, should appoint someone who is trained and competent and has a thorough knowledge of the LEV system. They should know what the parts of an LEV system are and what their function is, how to use the LEV system, particularly what a damaged part looks like. It's all well and good doing tests, but if you don't know that what you're looking at isn't effective, there's no point in doing it at all. They need to be doing regular checks, maintenance and repairs. and all records should be kept in a logbook. So in terms of maintenance, you should be trying to establish proactive maintenance. Prevention really is better than cure, and you're going to want to try to have this in place so that it's being done regularly and that it becomes part of your employees' working life, that they do these checks to make sure that everything is working properly and as it should. Follow the guidance in the manual. Record and review it regularly. Include your employees. There's going to be nobody who's better able to tell you if something doesn't sound right or doesn't look right than someone who's actually working with the system daily. Someone coming along from management who doesn't really use it won't have as much of an idea of whether something's wrong than your employees. Review it after review your maintenance after the thorough examination and test in case something's been highlighted that may need more frequent maintenance, more frequent checking. And if there are any changes needed to make the system work better, for example, rebalancing if there's been an additional branch added on or some change made. So in terms of frequency of maintenance, visual checks should be made at appropriate intervals. HSG 258 states at appropriate intervals. It doesn't, I think it goes on to say at least once a week. It should be done at least once a week, if not daily, or at every use. This way you just get into the habit of doing it, and it should become second nature to your employees. It includes the inspection, servicing, observation of the system, and any remedial work to maintain the system. And record all of your maintenance in a logbook, and if you haven't got one, get one. It doesn't need to be anything fancy. It can be a notebook beside your system where people jot down the checks that they've made, any findings that they found, and where they know that they can take the findings. If there's anything wrong, they can go to management and try and get it sorted quickly. So your logbook should contain schedules for regular checks and maintenance, records of regular checks, maintenance, replacement and repairs, checks of compliance with the correct way of working with the system, the name of the person who made the checks and possibly the date. Ian gave a very good illustration earlier of what a check should look like, and it should be readily accessible and located close to or beside the LEV if possible. So in terms of a manual is not the same as a logbook. A logbook is where your routine checks should be made. A manual comes from when your LEV system was commissioned. And again, if you haven't got one, get one. Contact the supplier of your LEV system. If you haven't got any information on what an optimal running conditions should look like, contact the supplier and try and get that information. If not, you may need to get a thorough examination and test examiner to come and do a commissioning report and then have them reassess the system against that. If they don't have any of this information, they can't assess. They don't have anything to assess the LEV system against. So your manual should include your design spec, including the purpose and description of your LEV system and how it works, how to use the LEV system, including any checks carried out to ensure fume control. Is it controlling exposure? It says compare with the workplace exposure limit if available. Now this isn't entirely relevant to welding because you want to make it as low as reasonably practicable, but it should never exceed the workplace exposure limit. It should contain the schedule, frequency and description of checks and maintenance. Any performance measurements when the system is performing optimally. So these are really useful because if you have this information and you're doing your weekly or daily checks, then you know what they should be whenever they're at peak performance and at the level they should be performing at. So you should have the static pressure at the hood in the duct, face velocity measurements and duct velocities, etc. A list of replaceable parts and potentially part numbers, and a list of things that are likely to go wrong so that you have something that you know that you want to check it against, so that if you are aware that something is likely to go wrong, that you know to look out for that. So this is just a list of things that are good to know. The suggested instrument calibration interval is 12 months. So if you are using instruments to conduct face velocities, duct or static pressures or anything like that, you're going to want to make sure that you're measuring what you think you're measuring, and the way to do that is to have your instrumentation calibrated. So do that every 12 months. Tell your workers about the health hazards from welding fume. I know it's been discussed before, but I'm just going to say it again. You are at risk of lung disease, lung cancer, kidney cancer, melanoma of the eye, COPD, asthma, and that's not an exhaustive list. If people are aware of the risks, they're probably more likely to use the equipment properly that you're providing for them. Provide supervision. There's no better way of making sure people do things right than if someone's standing over the top of them. Provide training. Make sure that they're aware of how to use what you've given them. Make sure they know how to face fit or how to check their mask to make sure it's working. Make sure they know if there are any leaks, what they're looking for. Involve managers in health and safety training. And keep training records and refresh it regularly. You're going to want to make sure that your training is fresh in people's minds, that they're constantly aware of what they should be doing, which is the most likely way of getting them to actually comply. So competence has been discussed before, and it is very, very important. It is a legal requirement under the Management of Health and Safety at Work regulations and cost regulations, and it means sufficient training, knowledge, understanding and experience to carry out the job that they're employed to do. The more serious the risk of failure, the greater the degree of competency required. It is so important that you get someone who's competent. Having a training course is just not enough. Anybody can go on a course, and yes, while it's useful and while it's informative, you must have someone who has the knowledge and experience and understanding of the system to actually perform what you need them to perform. So whenever you're selecting an examiner, you want to make sure that they have appropriate knowledge, appropriate capabilities, the necessary experience, and a training course such as P601, P602 would be helpful, but they don't have to have it to be competent. You're entitled to ask the examiner for proof of their competence. They should be able to provide you with reviews from past experiences, maybe people who they've done LEV tests before. You should be able to ask for that, and they should be able to provide it. So in terms of your thorough examination and test, the examiner, whenever they come to do the test, is going to need the LEV system commissioning report, the user manual, the logbook. Don't fill in the logbook just before they come, because they will know that it was only checked once, and if the system has not been performing properly, they'll be able to tell. Any previous thorough examination and test report, if it's available. Any changes to the system, the layout or the process since the last the last test was conducted. Any records of air sampling relevant to that LEV system or area. And they need to see the LEV system in use. So as I've included this picture again, so yes, the system is in place, they have a capture hood, but it's not being used properly. So they need to see the LEV system in use and make sure that people are using it as they have been trained to use it. And this is just a slide on what to expect during the thorough examination and test. It's conducted over 3 stages. So stage 1 is the thorough visual and structural examination. It includes measurement of duct diameters, inspection of the filter fabric if it's relevant, checking of cleaning devices, inspection of the fan, checks for indications of effectiveness, for example, not relevant to welding, but dust around the hood. If there's any visible welding fume getting past the LEV hood, or noisy equipment could indicate an unbalanced system as well. Stage 2 is to review the technical performance. So this is where they take measurements and do use visualization techniques such as smoke tubes or dust lamps, Tyndall beam, to visualize the fume. They'll also measure face velocity, duct velocity, static pressure, fan speed, fan rotation direction, and air cleaner performance. Stage 3 is the assessment of control of effectiveness. The examiner will look at all of the results from what they've already seen, and then to make sure that the LEV can continue to perform to its intended design and adequately control exposure, and only then can it be passed. It should not be passed if it fails any of the other aspects. This is just a slide showing the visualization techniques. So the smoke tube is used to see, visualize the airflow to check that it is being captured. And on the right-hand side, the picture on the left, is without the Tyndall beam or without the dust lamp. So it looks like really there's very little of the fume getting anywhere near the worker's breathing zone. And on the right hand side you can see with the fume illuminated, you can see that actually it's surrounding him, it's everywhere. So this is what Yvette was talking about, that you can't always see with the naked eye what's going on. So why are the measurements important whenever your examiner comes out and takes them? Primarily it's to make sure that your system's performing adequately, but it's also very, very useful to identify any issues or problems. So if you know whenever your system is performing properly what the static pressures, phase velocities, etc. should be, then if you test them again, it's very easy. If you can see that the pressures are higher or lower than normal, you'll be able to see if there's an issue, and more especially where it is, without taking the system to pieces and trying to find the source of the problem. So in terms of the thorough examination and test report content, this is what HSG 258 Chapter 10 states that should be in it. For anybody who hasn't looked at this, who has an LEV system, I'd strongly advise that you do. It pretty much spells out in bullet points exactly what should be in your thorough examination and test report. It's a really, really useful document. So you should have the name and address of the employer responsible for the LEV system, the date of the thorough examination and test, both current and previous, the identification and location of the LEV system, the process and hazardous substances concerned, the operating conditions at the time of the test, and if this was normal. This is important because if you have a multi-branch system that has 6 branches coming off it, and on the day of testing only 2 were in use, but normally 5 are, that's not normal conditions. So this is important to know. A diagram of the LEV layout and location with test points indicated. The general condition of the LEV system, serial numbers and photos. Photos are very useful, so they should be included if possible. It should have any information about the LEV, the intended operating performance for controlling hazardous substances for the purposes of COSH Regulation 7, the methods used for visualisation, so it could be visual smoke test, it could be pressure measurements, duct velocities, etc. Any results of any air sampling that have been carried out, info on how the LEV is used by the employees. So as I said before, just because it's written down somewhere that this is how it should be done doesn't mean that that's how it's being done. So it's important to see how it is actually being used by the employees. Information on general wear and tear, any repair or replacement of parts needed, the name, job title and employer of the examiner, the signature of the examiner, any minor adjustments or repairs required to make the LEV effective, and any critical defects identified. Now, the LEV report should have a prioritised list of remedial actions to be followed up by the employer. That should be the first thing you see, really, whenever you look at the report. It's very important. It should be kept for at least 5 years. That's the minimum that it needs to be kept for. It's also good as a reference to look back at if your performance is slipping. You can look back and see how it was performing before and what you need to get it to. Or it could form the basis of a manual if you haven't already got one. The report should not just be read and filed away. It should be read and any actions implemented, and it should be read by management. Everybody who's responsible for this system, you as the employer, you need to know what the report has said. So you need to read it and action anything that needs done. It is the employer's responsibility. So you want to check that everything that I've already said is in the report. It's up to you and the examiner as well to check that those points are all covered. So yes, it's a legal requirement, but you want to use your thorough examination and test as an opportunity to optimise and improve the system if there are any improvements that can be made, and also just to show workers that you actually do care about them and their health, that you're getting these checks done to make sure that the equipment that you've provided for their well-being is working properly. So this is just a quick slide about what's missing from a bad report. This is a few things that we've noticed from reports that we have had. So the hazardous substance to be controlled is left out. A diagram of the system is not there. It doesn't take too long to do a quick diagram of a system, and it's very useful to see what the test points were. especially to refer to the following year. Photographs, as I said, are very useful. The intended operating performance or current performance to compare to. If you haven't had a commissioning report done, or you don't have any reference to what the operating performance should be when it's performing optimally, what are you assessing against? You need to make sure that you have something to compare it to. There should be comments on how the operators use the LEV. As I've said, standard procedures not always applied. Just because you tell someone to do something a certain way doesn't mean they do it, hence the need for supervision and training. And passing a badly designed system. I commandeered this slide from a vet's report because I thought it was a really, really, really good example of a terrible design of an LEV system. It is absolutely not fit for purpose. Whoever thought that that was adequate to control the level of dust or in that small room is, yeah, they definitely need to have a look at things. And finally, who's responsible for the thorough examination and test report? It's both the employer and the examiner or company carrying out the thorough examination and test. You can't deflect, as an employer, you cannot deflect your legal responsibility onto somebody else. Don't request something that is less than a full report, and don't accept something less than a full report. HSG 258 is very clear and very concise in what they expect to be included in a report. And if an inspector comes out, that is what they will ask to see, and there's no excuse to not have it. It's given to you, and it's given to you very plainly what you should have. As an examiner, don't provide less than a full report. So, as I said, inspectors will ask for all of this information, and it's that old saying of buy cheap, buy twice, and you do get what you pay for. So if you do, you want to get someone who's reputable, who's competent, who will do your thorough examination and test properly and give you a good report that is something that's useful and that you will benefit from. Because if you buy cheap, you will buy twice or three times or as many times as it takes to keep the inspectors happy. But thank you very much for your time.